66 million years ago, a massive rock slammed into the Gulf of Mexico, famously wiping out the dinosaurs. We tend to think of that as the worst day in our planet's history. This data visualization, comparing the total percentage of life lost, reveals a much older catastrophe, known as the Great Dying. This event wiped out 90% of all marine species and 70% of land vertebrates. The most unsettling part is that no asteroid struck the Earth, no rogue comet appeared in the sky. Instead, the planet's own internal systems turned against the biosphere. 252 million years ago, Earth was stable and thriving. Giant amphibians dominated the river basins, and early reptiles hunted across dense forested continents. At that time, all land masses were merged together. This geographic map shows the supercontinent Pangaea, surrounded by a single global ocean known as Panthalassa. Then, the fossil record suddenly goes quiet. In a geological blink of an eye, these complex ecosystems simply vanish from the rock layers. Without a crater to explain the carnage, geologists were forced to investigate how a localized geological event could trigger a global biological collapse. The answer starts deep beneath ancient Siberia. A massive plume of magma rose from Earth's mantle, building immense pressure against the crust for thousands of years. When it finally broke through, it didn't form a single volcanic cone. Instead, thousands of fissures tore open across the landscape simultaneously. This created the Siberian Traps. For millennia, millions of cubic kilometers of molten rock flooded the surface. But lava is heavy and slow. It only burned what it could physically touch. The true global threat was invisible. These eruptions released unimaginably vast quantities of carbon dioxide and methane into the air. The magma itself didn't cause the mass extinction. This sudden, extreme injection of greenhouse gases initiated a systemic planetary failure. This flowchart illustrates how the failure compounded. The massive influx of volcanic gases overloaded the atmosphere, triggering a runaway greenhouse effect and extreme global heating. Global temperatures spiked dramatically, with surface waters in tropical oceans reaching lethal temperatures of 35 to 40 degrees Celsius. On land, terrestrial weather systems collapsed. Rainfall patterns shattered, deserts expanded across Pangaea, and massive wildfires swept through the remaining forests. As the forests burned away, their root systems died. Massive soil erosion clabbed the riverways, destroying aquatic habitats. With the plant life gone, herbivores starved, and predators quickly followed, collapsing the terrestrial food web from the bottom up. Returning to our flowchart, the disaster spreads to the water. The ocean acts as a massive carbon sink. Absorbing all that excess atmospheric CO2 caused rapid, severe water acidification, dissolving the calcium carbonate shells of marine life. This compounded with a second physical property. Dramatically warmer water holds less dissolved oxygen, causing widespread oceanic suffocation. As both factors converge on the chart, they create rapidly expanding dead zones where marine ecosystems dissolved or suffocated. The ocean had been a stable sanctuary for life for hundreds of millions of years. Now it had transformed into an inescapable, suffocating acid bath. But the dying oceans triggered one final biological threat. Inside those sprawling, oxygen-starved dead zones, populations of anaerobic bacteria exploded. Because these bacteria thrive without oxygen, they metabolize differently, producing massive amounts of a highly toxic byproduct, hydrogen sulfide. This lethal gas bubbled out of the stagnant seas and entered the atmosphere, actively poisoning the few animals that survived the heat and starvation. As the hydrogen sulfide rose higher, it severely damaged the ozone layer. Without that atmospheric shield, lethal ultraviolet radiation bombarded the planet's surface, destroying plant DNA. The cascade was complete. Earth's geological, atmospheric, and oceanic systems had all simultaneously inverted from life-sustaining networks into lethal biological filters. This disaster acted as a brutal evolutionary filter. Surviving wasn't a matter of location, it depended on possessing highly specific biological traits. Looking at this subterranean cross-section, you can see the survivors. The few species that endured the hellscape had low oxygen requirements, extreme heat tolerance, and the ability to live in deep underground burrows away from the toxic surface. Wiping out 90% of Earth's species violently cleared away the dominant animals of the era. This left massive ecological niches empty, providing the biological room required for dinosaurs and later mammals to evolve. It is a deep irony of our planet's history. Without this near-apocalyptic biological reset, modern life, including humanity, would never have had the space to exist. Scientists do not expect another massive eruption on the scale of the Siberian Traps anytime soon, but the mechanism of this extinction remains relevant. This comparative line graph draws a parallel between the ancient influx of volcanic greenhouse gases and the modern rapid release of human-caused greenhouse emissions. Researchers study the Great Dying as a severe stress test, showing how quickly interconnected global environments collapse when pushed beyond their limits. The ultimate lesson of the catastrophe is twofold. Life itself is resilient and will always find a way to return. But the specific planetary systems that sustain us are terrifyingly fragile.